Welcome to the Dynamic Number Project. In this video, I'm going to show you examples of games and puzzles that we've developed for number, operation, and early algebra. These activities were developed under an NSF grant, and they were originally built for the Geometer's Sketchpad software. But since then, we've updated all of the activities with new technology called Web Sketchpad. And Web Sketchpad runs entirely in your web browser, and all of the materials you're going to see today are free. So this page that I'm showing here contains links to all of the activities. And the activities sit on a blog that I've created along with my colleague, Scott Steckedy. Our blog is signofthetimes.org, and I'll provide a link below this video that takes you directly to this page on our blog. Now for each activity, there's a link to the blog post, and there's also a link to what we call the web sketch or the web sketchpad model. When you're learning about the activities, I would suggest going to the blog post, and when you assign these to students, you might give them the link directly to the web sketchpad model itself so that it doesn't have all the surrounding text around the interactive model. So now I'm going to show you just a handful of the activities that have been some of the most popular activities that our users have commented about. And I'm going to start with one that perhaps is the most popular, which is what we are calling zooming decimals. So here we have a number line, and we have a point on that number line, and we'd like you to predict what is its location. So I think the location might be, I don't know, 8.5. Well, I'm going to take my magnifying glass, my virtual magnifying glass, and zoom in on this interval between 8 and 9 to get a better look at what's happening. So we see when I press zoom that the interval is zooming out. We see the same point, and oh, I can read its value directly here. It's sitting directly on this tick mark, so that's at 8.7. As with all of the activities on our blog, you don't just play one game and one time through and you're finished. There are opportunities to keep playing. So when I press new problem, we get a new location of our point. And this continues where on the next page, not only do you zoom in once to get a better sense of where the point is, but after you've zoomed in once and I'm still not totally sure, we get to zoom in again a second time. And as the game progresses, we get to zoom in more and more until on our final page, we have multiple zooms. And bear with me as we see the ever finer approximations of this point. And 10 thousandths. And we still don't know the exact location. And in fact, we see that there is no precise location here based on how many times we've zoomed in. This value keeps going. And it's also very interesting to animate this point on the top number line. And it's moving, albeit very slowly at this scale, but as we zoom in, that same point we see is moving, well, quite fast actually. So it gives us a very interesting view of place value by seeing the point move at these different scales. For our next activity, we have an odometer. And this odometer has buttons that sit above the number and below. All of these buttons above have a plus sign, and if I press the plus sign above the ones place, it just adds 1 to my value each time that I press it. If I press the minus sign below the ones place, it subtracts 1. And that same pattern continues. For example, if I press the plus above the tens place, we're adding tens, or subtracting tens, and so on for each of these. So after students have played with this a little bit, we return the odometer to 0, and we ask, what's the quickest way that you can reach 100? Now, one way to do it albeit not very efficient, is to keep pressing this plus button in the ones place 99 times. But students discover quickly that there's a better way. They can jump all the way to 100 in one press, and then hop back by 1. So in just 2 presses, they've reached 100. And this gets very interesting when you start giving students other target values, and they begin to see what kind of patterns there are and what strategies they can develop to reach these target locations in as few button presses as possible. This next activity is one of my favorites. It's one that I developed while sitting on a very long bus ride in Alaska. And here we have 3 circles, a green, a blue, and a red circle. And we have some numbers that are going to serve as our add-ins, 1, 2, 4, 8, and 16. And our goal is to drag some or all of these numbers into the circles so that the sum of the numbers in each circle matches these targets. So for example, for a green sum of 12, I'm going to drag my 8 and my 4 into the green circle, and the circle lights up showing that I indeed have a sum of 12. Now for a blue sum of 27, let's see, I'm going to need the 16, the 2, and I think the 1, and that gets me to 19, so I'm going to need an 8. The problem is if I pull this 8 into the blue circle, now my green circle is no longer correct with its sum. So pretty soon into playing this game, I developed this idea, if I'm a student, that I'm going to need to start to overlap these circles. And now my 8 can reside in both circles simultaneously. And I still have some work to do now to get the red sum to be 29 and to do some more movement of my numbers to make this work. And again, every time I press new puzzle, I get a new challenge, and I can now go from having add-ins that go up to 16, up to 32, which means that my sums can go all the way to 63. And we have different challenges with, again, different add-ins. Here we have some add-ins which have negative values. And we provide a chance for students to create their own puzzles for each other, which is something we try to do whenever we can. So a lot of fun you can have with this game, and I would also point out, even though everything I'm showing you is technology-based today, this makes a really nice game to play at home if you have something like hula hoops that you can put on the floor. Our next activity is probably our most fancy activity we developed in terms of the graphics and everything that go with it. This was our attempt to develop a multiplication game that pulls out all the stops. So we have this bunny, and we have different levels where the bunny is learning to count carrots by being able to multiply. So in the early levels, where we have these carrots on a field representing an array, students might just be simply counting the carrots one by one and then telling the bunny how many carrots there are, and then checking by having the bunny hop along and collect carrots. And ooh, the bunny ate all the carrots. Now when we get to some of the later levels, these strategies get a little more sophisticated. Here, for example, we have bunny teams. We have a gray bunny and brown bunnies, and I can change the number of bunnies on each team by dragging the slider. And here we're modeling an array, a 6x4 array, where students can determine that, maybe it's easy to determine 6 times 4 if I first multiply 5 times 4 and then add to that 1 times 4. And if I enter the answer here, you'll see that when the bunnies jump, they actually model that. That first we see a lone bunny jumping, and then we see the remaining 5 bunnies jumping. And when I get to the very end here on the top level, there's some fog that obscures the carrots, which means that I can't just be sitting down and counting the carrots one by one. I need to be using some strategies. This next model in some ways is a precursor to the bunny times game that you just saw. Here we have a construct a building activity where you're told how many rooms on each floor, for example 4, and how many floors there are, in this case 5. And you can be entering then the total number of rooms and checking your result. And there are different levels here that increase the challenge by using larger numbers. And it's fun for students to actually be creating these arrays for themselves. Our next activity takes a traditional number grid and supercharges it with some dynamic properties. So here I have a grid that goes from 1 to 120, and I can count or skip count along this grid by any two values that I choose. So here, for example, we have 3 and 4, but I could pick other values. So let's skip count by 3s. I can show all the orange multiples of 3. And while this is going, let's also show the blue multiples of 4. And we see that some of our numbers are shaded half orange, half blue, indicating that they're multiples of both 3 and 4. And I can easily change either of these values. I could change 4 to 5 and see now which are the common multiples of 3 and 5. And I can also do things like change the number of rows and columns. So if I change the number of columns to 15, for example, here we see all the common multiples are now along this last column. Let's see, what am I looking for next? Here we have a fraction tool available to us to be able to see fractions as an area model. So let's say I'd like to use the circle model to represent a fraction. So I'll tap on this circle, and I see a preview of the fraction that I'm about to create, which is 1/2. My numerator is glowing, so I'm just going to click to accept that value of 1. And now my denominator is glowing, so I'm going to click to accept that value. And finally, the center of the circle is glowing, so let's just click to place our circle. So here's our fraction, 1/2. I can change the size of this circle by dragging this point, and I can change the fraction by changing either the numerator or denominator. Kids like to pick large numbers, so I might show 1/43rd. And I can also show fractions that are larger than 1. For example, let's make this, let's make that 8, and let's make this 3. So here we have 8/3. And I can also do something pretty interesting to make this more dynamic. Let's make the numerator 1 again. Let's make our circle bigger. And if I tap on the animate tool, I'm going to take this number that's glowing and attach it to the denominator. And now when I press animate, it's animating my denominator, increasing it by 1 each time. And I can see what happens to a fraction as its denominator gets larger and larger. Students might think the fraction itself gets larger, but this is a nice way of seeing that in fact it's getting smaller. My next activity also deals with fractions, but this time with the connection between fractions and decimals. And it's an activity that was created by Natalie Sinclair, a professor of math education at Simon Fraser University in Canada. Here we have the fraction 1/7, and we also have its decimal representation. But our decimal representation is, well, mighty colorful. It's 0.142857142857, and it's repeating those digits over and over. And I can drag this point to change the number of digits in each row. And the fact that each digit has a unique color associated with it allows me to more easily see the patterns that exist within the decimal representations. And I can change 1/7, for example, to 2/7, and keep track of how these patterns of the digits change and what relationship there are between different fractions. We also have a fair number of activities that give students practice in early algebra through some very engaging games and puzzles. Here's one where we have a grid, a 4x4 grid, and we have different shapes that sit within our grid: triangles, hexagons, a circle, and some squares. Each of these shapes has a secret numerical value. For example, the value of a square might be 7, which means that all the squares have a value of 7. And our goal is to figure out the value of each of these shapes. And we have some clues. We can press any of these show sum buttons, and when we do, for example this one shows the sum of the shapes in this column. And since there's only a square, we know that the square has a value of 6. I can then press another show sum button, for example this one, and it shows me that the sum of these 3 shapes is 21. And since I know that a square is equal to 6, I can use that to figure out the value of the triangle. When I'm done, I can press Show Answers, and I can press New Problem, which generates random problems for me to solve. I can also go to the Make Your Own problem, and I can create problems to share with a friend by choosing my own values for the 4 shapes, as well as which symbols that I want to use. And finally, we have another game that's been very popular. This one is indebted to the curriculum Everyday Math, and there's a treasure that sits on the coordinate plane, and we're going to try to guess where the treasure is. So for example, here, if the treasure is at the star location, and I guess that the treasure is at point A, I'm going to get a clue saying that the treasure is 3 away from my guess. In other words, to move from A to the treasure, I travel along 1, 2, 3 grid lines. So this is an overview of the activities that we have for the Dynamic Number Project. Again, I've shown you just a handful. There are many, many more. And I encourage you, if you try these games and you have some feedback for us, to email us. My email is on the YouTube page. Or you could also place comments on the pages themselves of the games. There's a space here for you to leave comments.